Okie dokes, boys and girls, we are on page 5 of the Unit 7A, I guess, technically, Unit 7A packet for inequalities. Okay, what we're going to do today is we're going to graph inequalities. And what that means is we're going to show all the solutions to an inequality on a number line. Okay, now, when you use a number line, typically you use dots to show numbers. Now, with inequalities, there are two different types of dots we're going to use depending on the inequality. So if we have an inequality like this says n is greater than 9. Remember, I'm just going to remind you of this. Remember, the less than looks more like an L. So we can tell that that's the greater than sign because it doesn't really look like an L. N is greater than 9. That means that any number greater than 9 would work for n. So that's why we might have to use a number line to show all the different answers that work. But the thing is, anything greater than 9 works, but 9 itself doesn't work because 9 is not greater than 9. So to show that, when graphing an inequality using the less than or the greater than sign, you're going to use an open dot on the graph. I know it's hard to see here, but because the inequality says 9 is greater than 9, 9 wouldn't work. But the graph is going to start at 9. Because any number greater than 9 would work, just not 9. So like 9.1 would work. That's greater than 9. 9.2 would work. And anything to the right, anything greater than 9 will work. So when you see a less than sign or greater than sign or a less than sign, you're going to use the open dot. Okay? All right. On the other hand, if you have an inequality like this, n is less than or equal to 10. When you have the or equal to sign, like a less than or equal to or the greater than or equal to, you use a closed dot. So with both of these symbols, you're going to use a closed dot on the number. Because if the solution was 10, 10 would work because 10 is less than or equal to 10. So we're including 10 in the graph, and anything less than 10 would work. If n was 9, 9 is less than or equal to 10, that would work. And so would like 9.8. 9.8, even though it's greater than 9, it's still less than 10. But anything above 10 would not work. So it's 10 or less. Okay? So I guess when we see these symbols, we're going to use an open dot. When we see these symbols with the or equal to, we're going to use a closed dot when we graph it. All right, let's try a couple. So let's take a look at this one. What's nice about these two here is that the numbers are on the number line. Here, the numbers are not there, but I'll show you a trick as to how to set that up. This says A is less than 15. Well, there are an infinite number of numbers that are less than 15. Now, first we're going to start by looking at this number 15. If A was 15, would this work? Is 15 less than 15? No, it is not. So because we have the less than symbol, which looks kind of like an L, we're going to put an open dot at the 15. Because although the graph kind of starts at 15, 15 wouldn't work. But anything less than 15 would work. 14.9 would work. 14.8, anything less. So we're going to show all the numbers that are less than 15. So we're going to draw our line going to the left. 15 doesn't work, but anything less would. So this graph shows all of the solutions that would make this inequality true. All right, so the first thing is you want to look at the symbol, see whether you have an open or closed dot, and then draw the graph from there. B is greater than or equal to 7. So it's good to read it too first, just to get a sense of where are the solutions going to be greater than or less than, and then we'll think about the dot. B is greater than or equal to 7. Now, when I look at this symbol here, I'm thinking closed dot. Because if it was 7, let's say, 7 is greater than or equal to 7. So we're going to go to 7 because that's the number we're starting at. And we're going to put a closed dot because 7 would be a solution. And again, I know it's a closed dot because it's the or equal to. Okie dokes, we're back here. So b is greater than or equal to 7. So we want numbers that are greater than 7 or equal to 7. The 7's already accounted for here. We're going to find the numbers that are greater than 7. That's going to be in that direction. So these are all the numbers that would work. 8 would work, 9 would work, 10 would work, 11. Everything above 7 would work. Okie dokes. Now, these ones have no numbers in the number line. So I'm gonna teach you what's called we'll call it the 5- method. Okay? 5- method means this. I'm gonna put a dash in the middle. I'm gonna put 2 dashes to each side. 2 dashes to each side, and this is how we're gonna label the numbers. We're only gonna put 5 numbers on the number line. So we're going to do 5 dashes. The number in the middle is the number that's in the inequality. That's going to be 6. Then we're going to label the other numbers. So you got 6, you got 7, you got 8, you got 5, you got 4. Now we're going to graph it. A is less than or equal to 6. So we're going to have a closed dot on 6. Less than or equal. A has to be less than or equal. So the solutions for this one, A has to be less than or equal to 6. That's going to go to the left. These are all the solutions that would work. Anything less than or equal to 6. Feeling pretty good. Okay, the 5- method. B is greater than 4. All right, let's put our 5 dashes, 1 in the middle, 2 on either side, because there's no numbers on there. We'll start with 4 in the middle, and then we'll fill in the rest. 4, 5, 6, count down 3 and 2. B is greater than 4. Well, it is a greater than, so we would have an open dot on 4, because 4 does not work as a solution, because 4 is not greater than 4. But anything greater than 4 would work. So we're going to go greater than 4. We're going to go in this direction. These are the numbers that would work that are greater than 4. Booyah. We're going to make sure to put an arrowhead, too, at the end of the line there. Okay? Now, at this point, if you want to try this one on your own, you can go ahead and try it. I'm going to do it as well. But B, that doesn't look like an L to me. B is greater than or equal to 10. So we'll put our 5 dashes, 1 in the middle, 2 on either side. 10 in the middle, because that's the number we're working with. Then 9, and 8, 11, and then 12. Okay. I'm looking at the symbol here. I know I'm going to have a closed dot because it's the or equal to 1. So I'm going to put the closed dot at the 10. B is greater than or equal to 10. So greater than or equal to. So we're going to go toward the numbers that are greater than or equal to 10. Okay, feeling pretty good so far. So far, so great. All right, again, if you want to go ahead and try this next one on your own, feel free. R is less than 7. Dash in the middle, 7. 2 dashes on either side. Fill in the rest. We got 8, 9, we got 6, and 5. Okay, I already know, looking at the symbol, it's going to be an open dot on the 7, because 7 wouldn't be part of the solution. 7 is not less than 7. So 7 wouldn't work, but we're going to start at 7. R is less, that looks like an L. R is less than 7. So we were looking at the solutions that are less than 7. We're going that direction. Okay, feeling pretty good. Again, try this one on your own here if you want, or you can do it with me. N is less than or equal to 21. Middle, 2 dashes on either side, 5 dashes. 21 is going to go here. We'll count up 22, 23. We'll count down 20, 19. All right. Looking at the symbol, I'm thinking closed dot because we have the or equal to. It's going to include 21. N is less than or equal to 21. we're looking at the numbers that are less than 21 or equal to. So that's why we have a closed dot, and we're going to go less than 21. Booyah. Okay. Feeling pretty good here. Well, this one's a little unique. The number line is going to look a little weird. X, that doesn't look like an L to me. That's greater than. X is greater than 1. The 5 dashes. The 5 dashes. 1's going to go in the middle. That's the number we're starting with here. We're going to go 1, 2, 3. And then we're going to go down to 0. And then what's 1 below 0? Well, it would be -1. Okay? Well, now we're thinking about our dot. We're starting at 1. Would 1 work here? 1 is greater than 1. That would not work. Open dot. Anything greater than 1 will work, though. X has to be greater than 1, so we're going to go greater than. Here we go. We're going to the right. See kind of like a pattern here. We're just kind of flip-flopping. That's kind of nice. Okay, last two here. Now this one's kind of cut off. I believe that's a D. I believe that's a D. Let's do our 5 dashes, though. 1, 2 on each side. Okay. 35, let's put it right in the middle. That's the number we're dealing with here. And then let's count up. 36, 37, 34, 33. Okay. D has to be less than or equal to 35. Now, looking at the symbol, closed or open dot, what are you thinking? What are you thinking? Because we have the or equal to sign, we're going to include that 35, because 35 is less than or equal to 35, so that works. 35 works. That looks like an L to me, so anything less than that would work. D has to be less than or equal to 35, so we're going to go here. So 34 would work, because 34 is less than or equal to 35. 33 would work. 0 would work, which is way off to the side. 0 is less than or equal to 35. We're golden. That broke the pattern, kind of. We're going left, right, left, left. So now this one is trickier than it may seem. I can't wait to do this one. This one's a bit different because notice the variable is to the right of the symbol. So we start with the number, then we have our symbol, then we have our variable. So let's see what happens with this. We're going to start off the same way, though. We're going to do our dashes. The 5 dashes. Now, this is why it's really important to know what the symbols mean and to read the inequality and understand what it is actually saying before you do the graph. 15 is going to go right in the middle. 16, 17. All right. This will be 14 and 13. Let's read this a couple times to see if we understand what it means. This does not look like an L, so it would be the greater than. 15 is greater than T. 15 has to be greater than T. So let's think about that. First, let's think about the dot. It's going to be at 15. It's going to be open because we have the greater than symbol. It's not or equal to. So 15 is not greater than 15. So we're going to have an open dot. That's supposed to be open, although it's kind of appears to be filled in a little bit. That's better. Okay, that actually looks worse because now I've erased it. Oh, I've gotten myself into a bit of a jam here. Okay. Let's try to erase it a little bit better. All right. I think this is going to work. That's better. Okay. Now, 15 has to be greater than T. So whatever T is, like let's check 14. 15 is greater than 14. Is that true? Yes. 13. 15 is greater than 13. That's true. Let's try these numbers. 15 is greater than 16. That's not true. So it appears to be anything less than 15 would work because 15 has to be greater than whatever T is. So whatever T is has to be kind of like it's less than 15. So another way you could write this actually, if you're going to flip this, you can flip. This is why I didn't mention this first. If you flip the numbers and the symbols, or the variables and the numbers, you also would have to flip the symbol. So if you flip this, you got to flip everything. So it'd be like t is less than 15, which shows it like that. So that's just another way of doing that. Having the variable first can be helpful, so you can't always do that if you wanted to, but in other ways, just to think it through like that. All right, gang, that's it for today. I'll check this tomorrow, and have a great day. If you have any questions, let me know, and I'll see you soon. Bye-bye.